My name is Larry Pierce. I am excited to be here, and I want to thank you for joining because I know your time is important and you've chosen to spend part of it with me. So I'm going to do my best to make it very much worth your while. And as Christian said, we've actually had several webinars recently where we have explored some advantages that MSC Apex offers in creating mid-surfaces. And in particular, we've seen how the mid-surfacing technology along with the direct modeling technology within MSC Apex can help you significantly reduce the time required to create a mid-surface model, a mid-surface mesh. And not only do these tools allow you to create the complex mid-surface models, but they do it, and this is key, they do it in a manner that's easy to learn and easy to use, which is going to greatly reduce the level of expertise that you are required to have in order to produce expert models. I know that makes me happy because honestly I don't have a lot of expertise. So even more important than that though is that we're not just going to make a mid-surface and you're just going to accept it. Oh, that's the surface I need. We're actually going to let you make the surface you want. We're going to allow you to capture your engineering intent, your best practices that can help you have a repeatable process. And more importantly than that, in a previous life, I was the guy that was presenting results, to clients, to customers, to peers, and if I'm going to present results and stand behind them, I want that model to have captured my engineering intent if I'm going to have to defend it, and that's very important to me. So a couple of weeks ago, I actually, and this would be trending 2 weeks ago, that's sort of the modern kind of thing. You're either trending or you're not trending, but 2 weeks ago, I presented some techniques and showed you how to create a mid-surface really fast in MSC Apex. Didn't take a lot of time, didn't take a lot of expertise, captured my engineering intent. We compared what we're able to do in Apex with more traditional methods, other methods that are available today, and we had 4 example models that took over 13 days but took less than 2 days in MSC Apex. And so I asked the question at that time, what are you going to do with your extra time? Because, 13 days to 2 days, that's a lot of extra time. So I asked, are you going to explore design alternatives? Are you going to look at more robust designs? Are you going to go to market faster? That usually is money in your pocket. Money in your pocket's greater profits. That's good. Of course, you could also choose to do other things with your extra time. You could actually choose to just have longer lunches. I'm not providing lunch today, but I am going to provide an idea of what you can do with your extra time. So we're going to go through the model that I did 2 weeks ago, and then we're going to add to it. And we're going to add to it by illustrating MSC Apex's glue technology. We're going to integrate a local refined solid model into a coarse grid shell model mesh that we're actually going to make. Okay? So 2 weeks ago, I started with this solid model of a shear panel. I shared with you several areas in this model that would make mid-surface extraction tedious, challenging, might require a lot of expertise, might require a lot of cleanup, and we looked at how we could apply MSC Apex's incremental mid-surfacing to avoid all that. Some of the problems that we had, and we'll look at these again in a few more minutes, but we had we had a tapered area where I really wanted, my engineering intent was to actually have the mid-surface at the middle of the tapered area. Initially it wasn't, so we looked at how to address that. We had a lot of alignment, a lot of misalignment in this particular model. A lot of surfaces did not line up per se. Sometimes the misalignment was because we had little flanges that were coming in that were slightly offset from one another. Maybe they had different thicknesses. As the example shows here, a little skinny sliver area would be little skinny sliver elements which would potentially produce poor finite element results. So I wanted to avoid that. It would be my engineering intent that the idealized shell representation would have alignment. Okay? So 2 weeks ago, I showed you how to apply, so what was trending 2 weeks ago, I showed you how to apply Apex's incremental mid-surface tool so you could quickly guide MSC Apex through the creation process to avoid the issues. And so the operative terms were that the incremental mid-surface tool allowed me to do this in less time, drastically reduced the cleanup. It didn't eliminate it completely. I don't want to mislead you there. There was a little bit of cleanup, but it was drastically less, and it was way not complicated. It was very easy. So therefore, it was all done with less expertise. And the most important thing, once again, having been there and stood up and had to defend my results, it captured my engineering intent. If I'm going to defend my results, I want to have my intent represented in the model. So in addition to creating geometry, a mid-surface geometry and a mid-surface mesh, we also applied thicknesses. This is just one button click in MSC Apex. Actually, it's two. You pick the mesh, you pick the solid. So you map the thickness from the solid onto the shell elements. You get accurate thickness information for both constant thickness as well as variable thickness areas. And if you want to relive the magic that was the presentation from 2 weeks ago, as well as a lot of other great webinars that we've done in recent weeks and maybe even in past months, just go to mscapex.com, go to the events area, and you can actually watch that. Okay? So what's trending now? What's trending today? We've sort of recapped what was trending a couple of weeks ago. What's trending today? Well, today we're going to do that mid-surface again. Okay? Maybe not in quite as much detail as I did 2 weeks ago. So we're going to review that extraction technique on this model once again, illustrating the ease of use, how it takes a lot less expertise than most methods, a lot less cleanup, and most importantly, capture my intent. And capturing my intent, once again, can help create something that's reproducible, which is actually good. And we're going to do more. So we're going to look at something we can do with all the extra time we're going to have. We're actually going to integrate a detailed solid section into my shell mesh model. So what's trending now is my demonstration. So let's actually get into that. All right, so here is MSC Apex. A key thing about MSC Apex is its learnability, and we've talked about this many times, how the various tools you can highlight go directly to animations, not animations, but videos that show you how to use that. That's available, as well as online or available tutorials that we distribute with the product that you can honestly learn how to use the product in less than half a day. So anyway, I just wanted to kind of mention that. Let's get into the mid-surfacing today, because I have a lot I want to do in the time we have allotted. And once again, I want to thank you for spending your time with me today. So if we look at this, just a couple of things. I just want to remind you that this outer flange is tapered. I would really like for my mid-surface to capture that. I'd like for it to be down the middle. All right. A couple of other things of interest here is if we look at these flanges, if we look at the top view, we can see that we actually have multiple thicknesses represented. The flanges are not all constant thickness. And if you can kind of visualize how they're going to extend and connect together, they don't always connect at a common intersection, which is not bad. I'm not saying there's anything really wrong with that, but especially if it's a little skinny area, it's going to produce poor elements and poor results. So my idealization, my engineering intent is to align those, okay? Because this is a idealized representation. This would be more or less a stiffness representation of this panel. So a lot of mid-surfacing tools that are out there, they try to be automatic. Okay, so we have some abilities to do that, one of which would be our constant thickness tool. So I'll just kind of illustrate it really quick. You'll notice that I've not removed any fillets here. I purposely have not removed fillets. I can. A lot of times that's sort of a prerequisite to doing a mid-surface, but the mid-surfacing functionality and capabilities in Apex are honestly so strong, it's not a requirement, it's not a prerequisite. If I actually look at what I get, though, with constant thickness, because this tool really was not designed to do this, I'm extending it beyond what it's really designed to do, I kind of end up with a mess. Honestly, using edge and vertex drag technology in MSC Apex, I could fix this, but there's a little bit of cleanup required here. I would like to do better, okay? I would like to do better. You can tell that maybe if I got rid of the fillets, did a little defeaturing, it would be better, but there's a lot that's missing here. So we really don't want to do this. So let's undo this, okay? MSC Apex actually has multiple undos as well as redos. So let's go and let's use the latest arrow in our quiver, okay, to tackle this task, which in MSC Apex is our incremental mid-surfacing tool. And the intent of the incremental mid-surfacing tool is in many cases you'll get something that's automatic, but in other cases where you have a few little complexities like we do in this model. In this model there's way more complicated models, and there's models that are simpler, but this is one I can do within the context of the time frame we have and talk about it. The incremental mid-surface tool allows me to guide the process, okay, to introduce my engineering intent into this model. It uses the concept of a face pair. So the first step is to actually look at the solid and actually figure out this face opposes this face. And so you'll notice that I've got a lot of different colors represented here. Those represent the face pairs. And we're going to attempt to create a mid-surface between those face pairs. All right? So let's actually just for grins, let's just say, you know what? Let's try to make a mid-surface here. So we're just going to select all the face pairs. We're actually going to make a mid-surface and see what we get. Maybe we get lucky, okay? And maybe we capture my engineering intent right out of the bat. You know, we can hope that it will work, but hope is not really a strategy, right? So I'm not expecting that it's going to capture my engineering intent. So let's look at it real quick. We do see one problem area up here. We've got a missing surface. That may not be a big deal. We may be able to fix that easily. But the thing that bothers me the most is if I do look in some of these areas, I do see that I've got misalignment, okay? I really would like it to be aligned there. I know that little sliver of a surface will produce some elements that might potentially produce bad results. Even worse than that, I've actually got an area over here where I've got some gaps between the surfaces where they didn't necessarily extend correctly, and I've got a really wicked misalignment problem right here, okay? And I can deal with this in MSC Apex. The direct modeling tools, the edge and vertex drag, honestly, I could clean this up pretty quickly, but I would actually like to once again reduce the amount of expertise required, and I just want Apex to do as much possible up front. So we're going to actually try again. I'm going to guide the process just a little bit here. All right? So we'll undo that. And so let's see if we can fix these things. Now, the incremental modeling tool provides you with 3 tools that will help you guide the process. One is a tool to edit face pairs where you can add and remove faces. One is where you can merge pairs together. We'll see how both of these tools work. And then another one is an offset tool. In other words, is this mid-surface right down the middle, or is it offset from the left or the right-hand side? Okay. So let's first look at this area where we were missing a mid-surface, okay? And I'm actually going to guess, it's my educated guess, that perhaps the little fillets, we actually picked up a few of the fillet areas as part of my face pair, okay? And that was sort of due to sort of some tolerancing issues, so we're just going to go ahead and remove those real quick. So if you do get something in a face pair that you really don't want, it's very easy to use the edit tool to actually remove it. Now that we've removed that, let's just do a quick check here. We'll pick our face pair, and we'll actually preview what the mid-surface might look like, okay? It comes in sort of as a transparent view, so I hope it comes through good on the WebEx. But I can see that I do have a surface there now where I did not have one before, and I can see that it's actually right down the middle, which is exactly what I wanted, okay? So we'll unpreview that. So one of the key features of the incremental mid-surfacing tool is it is going to allow you to preview before you actually create the mid-surface if you want to. That's a very powerful thing to do. Of course, Apex has multiple undos, so even if you had created it, you could actually undo if you made something that you didn't want later. So I also see that I have a few other little fillets that were included. So it was good to remove them over here, so it's probably good to remove them in these other areas. So let's go ahead and do that real quickly here. And so we'll find the filleted areas that were included, basically due to some tolerancing issues, perhaps. We'll remove those, and we will have edited our face pair definition. So now we got something that doesn't include those fillets. And let's now do another preview. And what I'm really interested in is what is this flange? What is this outer flange? I fixed this area. What's it going to do now. And the thing I'm really curious about is I've got two different face pairs here. How does that going to affect things in this case? So let's go ahead and we will preview that. So I will select this one and I'll select this one and we'll hit a preview. And we are going to find that we actually have a problem here, all right? And the problem is right there. We can see that we've actually got some misalignment. And the misalignment is because I have two face pairs representing that flange, and each face pair actually has a different mid-surface extraction. One is kind of trying to do it in the middle, and the other one's kind of trying to offset one side or the other. So let's unpreview, and let's fix that. And I think the logical thing to do here is that really this flange should be a single, it should be a single face pair. So let's go in and let's edit. Very easy to edit. So we'll just simply remove those. All right, so those are removed from that face pair. Something that's not part of a face pair will show up as just this light gray color here. And now I'm actually going to use the edit tool to add those back. All right. Once they're added back, they show up as a gold color, and there it's showing up as a single color, so that looks nice. Let's go back and preview that. It's just really powerful. It's honestly a stress reliever, okay, to be able to preview what's going to happen, because I know what's going to happen. I don't have to wonder what's going to happen. I know what's going to happen as a result of what I have done. It's honestly a great learning tool as well, because if you ever wonder, should I use the edit tool, should I use the merge tool, then by previewing and seeing how the tool is actually operating, it really assists you. So you're guiding the tool, but by previewing, the tool is kind of guiding you. So that's a really good symbiotic relationship, which is a mighty big word for me to say. So we can see that we've got a continuous mid-surface along this flange. We can see that it's down the middle, which was my engineering intent. Very happy with that. Going to unpreview that. So let's complete our work now. So we saw that it was a good idea to actually have a continuous face pair to get a continuous mid-surface for that flange. Well, if you recall, I had these other areas here. I had these other areas. I had this area. I had this area over here. There's actually another area up in there as well where I have misalignment, okay? So maybe it's a good idea to actually take this flange and this flange and make them part of the same face pair. So it was a good idea up here. Let's apply that here as well. So I'm going to use the merge tool, and I'm just simply going to merge these together, okay? Going to do a similar thing here, all right? And I'm not going to do it here, just simply because that offset looks large enough to get a decent sized element in there, so I'm going to let that one pass. If you also remember, I had some problems along this particular flange. In particular, I had some gaps in that area, so let's actually merge these together as well. I will have to say that merging the face pairs does not necessarily guarantee alignment, okay? I could actually have some offsets that were so large that would potentially cause it to not be able to do that. In this case, it's absolutely going to work. For more difficult cases, we actually have a mid-surface extraction method we call one cut, which is a little bit even better, per se, for the more drastic situations. We don't have that here, so we'll just go with this. So I have modified and edited my face pairs. I have previewed so that I know basically what's going to happen. So I'm actually ready to go now, all right? I might actually want to preview to see what happens in these areas, but I'm just going to go ahead and make my mid-surfaces. And once again, if it didn't turn out to be what I wanted, I could always undo, all right, and redo later. So we'll extract our mid-surfaces. And after we get our mid-surface extracted, I'm going to go ahead and hide the solid so we can kind of look a little better. And I can see that I absolutely have captured my intent. I actually have this meeting at a common intersection there. If I look in this area here, I had some gaps. I had a really, once again, a very messy looking problem here where this was supposed to intersect, and that's totally been corrected as well. So I've actually extracted mid-surfaces with just a very little bit of effort, very little bit of input from myself, and I've actually captured my intent once again. I've actually got the mid-surfaces that I want. So let's now go and see what cleanup we have to do. And there is a little bit of cleanup. Once again, we're going to reduce the cleanup, but there may be some cleanup required. In this case, we've extended most of the surfaces, but a few surfaces might need to be extended using edge or vertex drag. Okay, so I can use edge and vertex drag to actually extend if I want to, and do some cleanup operations. In this case, I've actually got quite a few places to drag, so maybe it's actually a little bit better to just simply come in and just simply use our extend surfaces tool, which sort of automatically, or automagic if you want to call it that. Everywhere I see a red edge is a free edge. If I see green or yellow, well then that's an edge that we would consider to be stitched, and you're going to get a congruent finite element mesh there. So I've done it. I have got my mesh. I've actually got my surfaces, so we're actually ready to mesh now. So let's go to meshing. We're going to do our surface mesh. I've done this, I'm using inches today, but I remember the mesh size, or a good mesh size, in millimeters, so I'll go ahead and enter it in millimeters. And that'll also illustrate the fact that MSC Apex does understand units, understands unit conversions on the fly, which is a very cool feature. So we've actually got a mesh now. You can see we've got some nice washers around the holes, but I really don't want the holes in this case because the fasteners might be represented as a point-to-point type connection using a bushing element, a bar element, such as that. So I'm actually going to get rid of those holes. I'm going to use our defeature tool to do that. All right. This will illustrate also the generative nature of MSC Apex in the sense that changes that I make, other things automatically update. In this case, I changed the geometry, and the mesh automatically updated as a result of me getting rid of the holes. I'm also going to get rid of some of the fillets that might remain. I could have gotten rid of them on the solid. I'm just going to go ahead and do it here because this is, once again, an idealization, more of a stiffness representation. Okay. So we've gotten rid of the fillets, like in these little areas right in there. Let's actually update the mesh just a little bit because I can improve the mesh in a few areas. And let's actually do that by mapped meshing. Okay, so we'll actually select a few faces here where I think the mesh could be just a little bit, I guess the correct term would be prettier if a mesh can be pretty. So we'll pick a few of these faces. Mapped meshing doesn't necessarily have to have 3 or 4 edges. It can work on geometry that has more than that. So we'll pick a few of these and update the mesh in a few instances. I think I'll let that be it. I could also do a lot of other things. For instance, I could come in here and if I wanted to refine the mesh in certain areas, I can adjust the mesh seed if I want to. So I have a lot of different options for improving the mesh to meet, once again, my intent. All right. So we're going to let that be our mesh. Let's actually just go ahead and I've got an aluminum material here. We'll go ahead and assign that. We'll also go ahead and assign our shell element behavior. We'll do membrane bending and include the transverse shear effects. Okay. Now I want to introduce my fasteners, okay, because remember I took the holes out, but I actually have some points that represent where those holes were at. And so let's actually see if we can get the mesh to update and adjust. Remember, I was going to use a point-to-point connection. So you can see my mesh does not really adhere to where those points are. So we're going to introduce what MSC Apex calls a seed point. So I will select, don't want to select all those nodes, so let's hide those real quick. I'm going to select those seed points. And let's use a little bit different tolerance. These points are not directly on the surface, and so that tolerance is used to actually associate the point with the mesh, even though the point is not directly on the surface. And we'll do that. So Apex has actually now adjusted the mesh. So if you remember, before we actually had a situation where the nodes didn't necessarily align with those points, but the mesh has now been adjusted so that that is true. And if I look very carefully, we'll see that Apex denotes the seed point with a little triangle over the point, a little dotted line showing you the node, in this case, that is associated to that point. We know that change is the ever-present constant, so a really cool capability here is I can actually come in and start moving this point around, okay? And as I move that point around, which, you know, engineers always do what-if analyses. We're always trying to make things better and improve things. Maybe we might believe we could improve it by moving the fastener location. So it's very easy to do that in MSC Apex thanks to the generative nature of the product. I'm going to undo that. All right, so let's get ready now. We want to do a quick analysis, and then we actually want to look at what we can do with our extra time. So let's go ahead and let's introduce a constraint here, all right? We're going to constrain this flange. But first, before we do that, I need to apply thickness. Let's do that. So let's apply thickness. Sometimes I get my cart before my horse. So I will now do thickness, and so let's actually do this. It's basically 2 clicks. I'm going to first do a constant thickness just to kind of illustrate that. So we'll select the elements, we'll select the solid, and we've got a constant thickness. We can actually see that we know that this is a variable thickness, but we've chosen to do it as constant. I'm actually going to update that to be variable. One thing I do like to point out is there's actually a small surface right in here, and if we actually bring the solid back, we can see that that thickness is a little different than the other constant thickness because of the presence of that fillet. So let's actually fix that, because I want that to be the right thickness in that area. So we'll close the thickness tool, we'll bring the solid back, and we'll just quickly defeature just that one fillet. All right, just for the purposes of our thickness calculation. Notice that the only reason that fillet affected the thickness is because there was a small surface there. These other thicknesses, these other fillets, it's actually using the thickness that's out in that area. So we'll come in now and we will hide the solid very quickly. We'll go back to the thickness tool. We will select our elements. We will select our solid. And we will have constant thickness, and you can see that we've got the same thickness in that area just simply because we removed that fillet. That fillet is now not influencing the thickness calculation. So let's actually now go in. We want to update it just a little bit. Let's actually do a variable thickness on this flange over here, because this flange is a variable thickness. So I will select the flange. I will select the solid. And you can see by the different colors that we really have captured the variable thickness. It's actually variable thickness sort of up and down as well as front to back. So there's actually a lot of variable thickness in that, and we have captured that. So let's now go ahead and apply boundary conditions and run a quick analysis. So I am going to constrain this back flange, and I'm just going to completely constrain it because I'm not doing real work. I'm not going to have to defend this work that I have done, so I'm sort of making it up on the fly. So we're just going to constrain these faces, okay, of this back flange. So we've introduced some constraints there. And for the loading that we're going to apply, I'm actually going to introduce the loading through these fastener points, okay? So I'm going to introduce the loading through the fastener points. So I'm going to apply a load. If we look at our coordinate system here, it's going to be a shear load in this direction as well as a bending load going up and down, all right? And my magnitude, since it's not a real problem, I'm not obligated to have a magnitude that might make sense. We're using really a low force. I'm going to apply it directly to this point. You'll notice that Apex gives us a nice little graphical representation of the force that allows us to graphically manipulate both magnitude and direction of the force, but I'm just going to accept it because this is what I have here. All right, and now I want to apply that same load to some other locations here. So if I go look in the model browser tree, I'll see that I've got a load that I have applied. This represents the magnitude and the direction, and I can, review the properties of that if I want to. In this case, I'm just going to apply this particular force to some other locations, and I want to apply it to just the red dots here, because the red dots represent where my fasteners are. And I will apologize, I've included a few points I did not want to include. So let me actually hide the mesh and hide the surface now. It'll be easier to pick. So we'll simply select those points. We've got those points, and we've got the force. It just puts a single vector at that particular location, but you can see that the force is actually at all of those points when I highlight where the points are. So we'll come in and we'll bring back our surface and our mesh. We've applied, I think, everything. So let's actually just run this real quick and get to what you can do with your extra time. And I think I'm doing well on time as well. So we're going to set this as our analysis context. What that means in Apex is this is the portion of the model that I want to execute. I want to analyze. I could have an assembly or sub-assemblies. I could have all those kind of things. And we are now going to look at the analysis readiness panel. This is where Apex lets me know if I'm ready to actually run analysis. It's automatically checking my element quality. It's automatically looking to make sure that I have all the components that are required to do this analysis, such as thickness and materials and such. It's telling me that I've got a few elements that they're not perfect, but I'm running short on time. So we're just going to actually execute this. Analysis is now running, and we'll be done in just a minute. We'll go to post-processing, and we'll just quickly create an animation and a fringe plot of our result here. We can see that it's actually kind of bending a little bit. All right. We'll look at our results. And this model really represents more or less just a stiffness representation. But I'm going to pretend for a minute. My daughter's really great at playing pretend. I'm going to pretend for a minute that it's really a much more high fidelity model than perhaps it really is. And I'm looking at these areas here where I'm getting some high stresses. And once again, I'm pretending that I think that's significant. All right. So let's actually go in and let's turn on some hot spots here. And I can see that, you know, I do have a couple of areas that actually are critical here, and I'm actually going to, in this case, I'm just going to look at this particular area. It's not exactly the maximum, but it's going to be the area of interest. Perhaps this is an area in the model where we've had a fatigue problem in the past, so I want to investigate this just a little bit more. All right. So we'll go back to our model now, and what I would like to do at this point is I would like to actually introduce into my model a submodel of the solid, so not the entire solid, but a submodel of the solid that represents this local area here that I want to look at in a little bit more detail. So what I'm going to do that is I've actually got a surface here, so let's bring that surface in. That surface has got a little hole in it, okay, and I'm going to use this surface to sort of slice and dice my solid. All right. We'll do this with our push-pull technology. So I'm just simply going to select this surface. I get a push-pull manipulator. Notice that Apex, of course, is very, graphically oriented. The direct modeling is that I spend my time directly interacting with the model. So by pulling that surface through the solid, I've actually subtracted out everything except what I wanted to keep in this case, which is this little subset of the model. Okay? I would like to replace in my shell mesh, the shell mesh portion that represents where this solid is. That sounds like a tongue twister. So we'll come in now and we will split all of these surfaces on the shell mesh representation. We will split those. Okay. So I will select what it is I want to split, and I want to split at these faces of the solid. Okay. And we want to integrate this solid. We're going to mesh it, but we're going to integrate this into the existing coarser grid shell mesh. So I'll now need to come in and actually delete out. I'll need to delete out the portions that I am replacing with the solid. So we'll select those. Okay, so we'll select right there. Okay, and oops. Not splitting them, I'm deleting them. There we go. So we've deleted that out. And we, of course, are going to replace that with this solid. So let's go in and do that now. All right. So I want to mesh this solid. And because this was the area that I was kind of interested in, I'm actually going to want to control the mesh in that area. So I'm actually going to introduce a surface mesh on that region. Okay, let's use a much smaller mesh size. I'm going to do a surface mesh on that region so that I can actually control the mesh in that area. So I've put a surface mesh. The solid mesh will automatically match that. I'm actually going to use some seeding here just to kind of refine it a little bit more. So I'm going to make sure that I have 2 elements through the thickness of the flange here. Awesome. Okay, I think that's going to be sufficient. I also want to control the mesh on these other fillets of the solid. Once again, maybe those are fatigue critical areas. I'm going to do that with our feature-based mesh settings. Okay, so if I actually go and use the push-pull tool, I can see that this fillet is basically 1/4 of an inch, and I can see that this fillet is basically 1/8 of an inch. So let's introduce some mesh settings to kind of capture that. So the feature-based mesh settings is going to apply a mesh pattern to the particular features. I'm interested in this case in the fillet. So we'll come in and we'll sort of introduce a couple of different areas here that we can control. I remember I had, we'll make this a 1. So I remember I had like an 1/8 of an inch. We'll do something in there. I had an 1/8 of an inch. We'll do something like in that area. And I had basically 1/4, so we'll do something in that area. So for this one, I actually want, let's say, 5 elements or maybe 6 elements around the face. And in this one, perhaps I just want 3 for the smaller one, so we'll do 3 there. All right, we'll turn that off. Now we will go to our solid meshing. We're going to create a tet mesh here. I am going to make that tet mesh, let's say 1 millimeter. Or maybe I'll make it 2. Not quite as fine. I want to capture the feature-based mesh definitions that I created, so I'll turn that on. I'll enable that. And I'll select my solid. All right, so we've got our mesh here, and if we actually review our mesh just a little bit here, what we will find is that if we review our mesh just a little bit here, what we will find is that we actually have captured the feature-based mesh settings that we were really interested in by having like 3 elements on the small fillet, having like 6 on this fillet, and we've even captured our refined mesh in this area where we created a seed mesh, because this was the critical area. This was the area that we were interested in. That particular area does not have properties, so I'm actually going to delete it. It was just used to get the tet mesh. It is not going to be used in the analysis, so let's actually delete that. Okay, that goes away. At this point, I've got really 2 separate meshes that are not joined together. I'm going to join them together using MSC Apex's glue technology. The glue technology is just give it a tolerance. It looks to see if the bodies and the elements are within the tolerance. If they are, then they're going to be glued. So we'll just simply select both of these regions. The glue has been accomplished. It's very useful to actually just show just the glue, so I'll show only the glue. This allows us to know where the glue is being applied, where the elements are being connected, and which element faces, which element edges are actually participating in the glue. This allows us to know a priori before we do the analysis, and this is all enabled by the fact that the solver is integrated into MSC Apex. We're actually using solver methods to generate this data so that we know once again before the analysis if everything is actually going to work out for us. All right, so we'll simply show the whole model, and we'll actually go back and we'll turn off the glue so we don't actually see the glue this time. So we're ready now to actually rerun our analysis. So I don't have to do anything else because of the generative nature of Apex. We know all our property information. We still have our boundary conditions, even though I've made quite a lot of extensive changes to the model. So we'll just simply hit run, and the model will run again. And this will take just a few minutes, a little bit longer than it did before because I've got these solid elements in there, but it's still going to be very quick. So we've actually completed our analysis. We can go to post-processing now. Let's actually turn on an animation, and let's turn on like a stress fringe. Fantastic. So I have now integrated and glued, and you can tell the glue is effective because I can actually see the solid. I can see the solid and the shell mesh moving together. You can see that I probably have a better representation of what the stress is in this fillet, which, you know, I'm pretending, but this is effectively where I'm pretending my critical area is that I want to investigate a little bit further, and I've actually integrated a more refined solid mesh directly into a coarser grid shell mesh in this case. And of course, I'm applying constraints and loads to the shell mesh that's being transmitted to the solid mesh through the glue that's in MSC Apex. Can actually look at, for instance, the displacement plot as well if I want to see like fringes of displacement, and I can see how uniform those fringes are as we pass through the glue area there. Well, that's actually all I had to share today. I hope you have enjoyed it. We created a mid-surface of the shear panel, very similar to what we did a couple of weeks ago. And then I shared with you what you can do with your extra time, because you are going to have extra time using MSC Apex to create your mid-surface model representations. And in this example, rather than taking an extra long lunch, I actually chose to refine my analysis by integrating a more refined, solid chunk, and I integrated that into this coarser grid shell mesh by using MSC Apex glue technology. Well, that's all I have to share today. I do thank you for your time.